Here we're given the expression for a curve in terms of x and y, where x and y are mixed together and multiplied, and we're asked to find the gradient dy by dx in terms of x and y. So because x and y are all multiplied together, we don't have y as a function of x, then we're forced to use implicit differentiation. That's where we differentiate in position. So the first thing we're going to do is to differentiate xy cubed. It looks like it's a product of x and y cubed. So we're going to use the product rule. So I need to differentiate x and differentiate y cubed separately. So the product rule, remember, is u dash v plus u v dash. So I'll differentiate each term separately. So the derivative of x is just going to be 1, and I'll multiply that times y cubed plus x multiplied by the derivative of y cubed, which is 3y squared dy by dx. Then the derivative of 2 is 0, and the derivative of 3x squared y, again, that is product rule. So we're going to have to treat that as a product of 3x squared and y. So I'll differentiate the 3x squared, and that'll give me 6x. And I'll multiply that by y, and then I'll add that to 3x squared multiplied by the derivative of y, which is just dy by dx. Now the question is asking to find dy by dx. So really, it's no good having dy by dx on both sides of the equal sign. So I'm going to move this dy by dx to that side, and any term that doesn't have dy by dx on it, I'll move that to the right-hand side. So if I take dy by dx as a common factor, you have dy by dx into 3y squared x minus 3x squared. That's negative because this positive, when you move it or you subtract it from both sides, you end up with a negative. So that's equal to 6xy minus y cubed. And if you divide both sides by this term here, you end up with dy by dx equals 6xy minus y cubed divided by 3y squared x minus 3x squared. So that's my answer for part A. Dy by dx is right there. So that's the expression for dy by dx. The question then goes on to say, find the equation for a tangent to the curve at the point 1 minus 1. So to find the equation of the tangent, you would need a point and the gradient. Point is no problem because that's given. So y1 would be negative 1 and x1 would be 1. So that is not a problem. To find the slope or the gradient of the tangent, we would need to find dy by dx. So let's do that. So dy by dx at the point 1 minus 1, we'd have to substitute 1 and minus 1 instead of x and negative x and y. So in the numerator would have 6 times 1 times negative 1, that's negative 6, minus 1 cubed, that's plus 1. And in the denominator, we'd have 3 times negative 1 squared times 1, that's 3, minus 3 times 1 squared, that also gives you 3. So that's undefined. So dy by dx, it sort of approaches infinity, it's undefined. So that suggests that the gradient, so the tangent line will be a vertical line. So it'll be a vertical tangent. And the equation of a vertical tangent would simply be x equals 1. So that would be the equation of your tangent. I know that because the gradient is undefined, the gradient is infinite, and that only happens when you have a vertical line. So a vertical line is defined only by its x value, and the x value is given in the question as 1. So we wouldn't be using this, we'd simply say x equals 1.